Hello, my name is Alion Pierce, and I'd like to demonstrate and describe for you the disaster recovery robot that I created. So, first I'll start with the statement of the disaster recovery problem. So, in this scenario, there's a building, which is specifically a dormitory of a boarding school, and it's on fire. And in this case, the fire has completely enveloped the third and fourth floors, but the fire department has deemed it unsafe for the firefighters to go into the building because the part of the roof has collapsed. And because of that, and because of the fact that it's unlikely that any students are in the dormitory currently, since it's the middle of the day on a Wednesday, meaning that the students should be in class. Because of those two reasons, the fire department has said that the firefighters shouldn't enter the structure. And so instead, the firefighters have deployed the disaster recovery robot, which is named Suri the Searcher, instead. Alright, so a summary of the environment and the obstacles. So I'm gonna do that now. So the environment, so I'm gonna pull this up for you. So in the exact environment in this graphic here is one of the bedrooms in the dormitory. So that's where Suri the Searcher is currently. That's the robot, Suri the Searcher. And the obstacles are as follows. So this is a bed. This is an overturned dresser that is on fire. This is a person. This is a wall, that's another wall, this is another wall, and this is the fourth wall, which has been cut down so you can better see what's going on inside the room. Yeah. Alright, and then now I'm going to give you a summary of the robot's goal and objectives. So the robot's main goal is to find people, basically. Find victims that are still inside the burning structure. And its objectives along the way are to avoid any obstacles that are in its way. And yeah, that pretty much sums up the robot's goals and objectives. Alright, now I'm going to give you a description of the robot and its architecture. So as I said previously, my robot's name is Suri the Searcher. And that's because it searches for people, searches for victims within the burning building. And so now, as for its architecture, so as you can see in this this picture here, Suri has 3 different sensors. So there's the front red sensor, there's the back red sensor, and then there's the front yellow sensor. So I'm going to tell you what those all are in detail. So the front-facing red sensor and the back-facing red sensor are both navigational sensors. Now, to start with, all 3 of these sensors are proximity sensors, which means that it can tell, that something is there, basically, without having to touch it. So that's what proximity sensors means, and all 3 of them are proximity sensors. But let's talk about the 2 red ones now. So the front-facing proximity sensor, the red one I'm talking about, and the rear-facing red sensor, those are both sensors used for navigation. So when either of those sensors encounters an object, Suri responds by stopping, like not continuing in the direction that she was going before. So she just stops whenever one of those sensors detects something, and then she reverses direction. That way she doesn't run into whatever one of the sensors detected. And this yellow sensor right here, it's longer, this front-facing yellow sensor here, and that sensor is used for purposes of human detection. So that one is able to detect humans, basically, and it can tell whether or not it's looking at a person or if it's looking at some sort of other object. And so that yellow sensor allows Suri to accomplish the mission for which she was created, which is uh, identifying people, identifying victims that are still in the burning structure. Another feature that I implemented is the green color of Suri, and that bright green color is for purposes of visibility, because visibility in burning structures is often pretty low. So I made Suri bright green because that contrasts directly with the most common colors of a fire, which are red and orange. And that's really useful because, it makes Suri less of a tripping hazard. People are less likely to trip over her. It also makes it easier to locate Suri. Let's say something goes wrong with her location beacon and like the firefighters can't find her. Well, it's easier to locate her if she's bright green. And it also makes it easier to tell the difference between Suri and a victim that may be in need of assistance, because humans aren't bright green. So, all right, so let's talk about the next thing. So now I'm going to talk about. Oh, so this one's a demonstration. So I'm just going to demonstrate for you how Suri acts in this scenario. So let me play this. Alright, so as you can see, as soon as that red sensor meets the wall, Suri backs up. She stops and reverses course. See? And then you can see the back sensor in effect here. Right there. She bumps against it, so she adjusts course so that she doesn't crash into whatever object it detected. And this yellow sensor here, it searches for humans. It can identify whether it's looking at a human or not. And right there, it detected a human, and Suri is responding by saying, "I found a person," whenever she detects a human. See? And she only says it while she's actively detecting a person. And as you can see before, the yellow sensor turns green while it's actively detecting a person. Alright? So, and let me talk about some more about the robot's capabilities. So I pretty much talked about the robot's main capabilities before, but let's talk a little bit more about some of the concepts that Suri displays. So like a lot of other artificial intelligence, Suri displays Suri displays reasoning. And what that means is Suri displays reasoning skills because she has the capability to make decisions. For example, she's able to decide which direction to move in by using the input from her sensors. Also, Suri is able to decide whether or not an object is human, and she does that by using her human detection scanner. And Suri also displays knowledge, which is another concept often displayed by artificial intelligence. And Suri displays knowledge because she has the ability to collect information about her environment. And for example, Suri can determine if there's an object in her path by using both her front-facing and rear-facing navigational sensors. That would be the red sensors that I showed you before. And she's also able to determine if there are any humans in her environment by using her human detection sensor. That's also a form of gathering knowledge. And Suri is actually able to act on the knowledge that she gathers. That means that Suri is able to display intelligence as well. So, for example, if Suri learns that there's an object in her path, so now she possesses the knowledge that there's an object in her path, right? Well, she acts upon that knowledge by stopping and reversing course so that she doesn't collide with the detected object. That displays intelligence. Another example is when Suri learns that she's looking at a human, right? Which means that Suri now has the knowledge that, she's looking at a human. Well, Suri acts upon that knowledge by outputting a message saying, I found a person, So that displays intelligence. Intelligence means acting upon knowledge, acting upon gathered knowledge. Suri also displays the concept of displays the ability to deal with uncertainty, and that's another concept that artificial intelligence sometimes possesses. So this is demonstrated by Suri's ability to navigate in an environment that Suri didn't have any knowledge of, like any previous knowledge of before. So Suri is completely new to an environment, and she's able to successfully navigate around in it. And this is due to her navigational sensors, right? Which allow her to pretty much navigate herself around on the fly. And they allow her to learn about her environment. And Suri also doesn't possess any prior knowledge regarding the number of people present in her environment. So this is something she has to learn on the fly as well, and she is able to learn about that on the fly by using her human detection sensor. She doesn't know anything about, the number of people present or the whereabouts of any people, but she's still able to, locate people. And that's another sign of Suri's ability to deal with uncertainty. Alright, so lastly, I'm going to give you some ways that the prototype could be improved. So, one way that Suri could be improved is, well, right now, Suri she's not able to create a mental map, or like she's not able to create a map of her surroundings, right? Pretty much every time the sensor detects something, it doesn't store it in internal memory or anything. Suri's algorithm right now is pretty much just detect an object, oops, can't go there, let's back up, right? Or let's go the other way. So one way that Suri could be improved is by storing the stuff that she learns about her environment in memory. That way she would be able to make a map of her current environment, and that way she can tell what parts of the environment she searched and which parts she hasn't searched, Because right now she's just kind of blindly searching around, not knowing what she's searched and what she hasn't, right? And so it would make it a lot more efficient if she were able to make a mental map. And that would also stop her from bumping into stuff so much. Or not bumping into stuff, but almost bumping into stuff. Because right now she's only navigating around based on whatever her sensors detect, right? Another thing that would be of great improvement to Suri would be using an advanced search algorithm. If we were to implement that into her design, it would make her searching a lot more efficient and directed. Because right now, Suri is pretty much searching blindly. She just pretty much searching blindly in the environment for people. But if we were to implement an advanced search algorithm, such as a grid search, then her searching would become a lot more efficient. So what a grid search is basically Suri would first search the environment in tight parallel lines, and then once she's done doing that, she would go back and search the environment again, like the same environment. She would search the same environment again using a second grouping of tight parallel lines, but the second grouping of lines would be perpendicular to the first grouping of parallel lines. So that would form a grid pretty much, and that would enable her to search pretty much as thoroughly as you can. And searching thoroughly is really important in this case because the consequences are pretty bad if she misses a victim in need of help. We can't really afford mistakes in this type of environment. Alright, so there you go. I've explained and demonstrated about Suri the Searcher, which is my disaster recovery robot. Her purpose is to find humans within burning buildings. Alright, thank you for watching. and have a good day.